I'm from the Office of Continuing Education, and we have hosted the Fairhaven Lecture Series here at Fairhaven Senior Services since 1983. And we've always enjoyed folks from Fairhaven here in the audience as well as the general public. We're not able to open our lectures to the general public at this time, so I'm actually recording it and going live on Facebook. We have a Facebook audience who's watching live, and we record the lectures that we post on our website later in the week. So if you ever want to revisit any lecture since 2012, you can do that on our website. But let's go ahead and get started for today. We'll talk climate change. Dr. John Frye has been at UW-Whitewater since 2011. He's an associate professor of geography in the Department of Geography, Geology, and Environmental Science. He earned his bachelor's and master's degrees from Ball State University and his PhD in geography in the Department of Geography, Geology, and Environmental Science. He earned his bachelor's and master's degrees from Ball State University, and his PhD is from the University of Georgia. Dr. Frye is a broadly trained physical geographer with emphasis in meteorology and climatology, and his research interests focus around extreme weather events. His studies have included examining extreme weather at the climate scale, which is the long-term patterns, meteorological scales, why a particular event happened, when and where it did, and the societal impacts. How does it impact people and property? Dr. Frye is a storm chaser and has traveled all around the country chasing storms. Please welcome Dr. John Frye.
Thank you, Carrie, and thank you everyone for joining us today. As Carrie said, I'm Dr. John Frye, and we're going to be talking a little bit about climate change today, a topic that you probably heard quite a bit about. It makes the news very frequently, especially in recent years. And I want to kind of talk more about this and kind of get this down to our level, where we are in the state of Wisconsin, and kind of really examine what's going on in our state. Now, we've heard about climate change. We've heard about, the terms global warming, and, that's kind of looking at climate change at that very broad scale, the entire planet, and the warming that's going on around our planet, which is important for us to understand what's kind of impacting the planet. But again, today, what I want to focus on is how is this impacting us here in the state? And we'll talk a little bit, as Carrie mentioned, I also am not only interested in the weather and climate aspect, but I want to know and I think about how this impacts society. And so we're going to talk about that a little bit as well as some other environmental concerns that we have due to the changes. And so what we're going to examine today is looking at temperature changes. We're going to focus on that and looking at it at the seasonal scale. Again, we hear in the news all the time that climate change is happening, our global temperatures are increasing, they have been since the early 1900s, and all of that is true. But how is it changing here, in particular in the state of Wisconsin, and also how are those seasons changing for us? And this all kind of, I've thought about this many times before, but earlier this year, about the same time that Carrie reached out to me to see if I'd be interested in talking in this series and giving another presentation, I had read an article that was looking at and examining how different parts of the world and the seasons in different parts of the world are changing because of this global warming that we are experiencing. And the researchers here, they were painting with a very broad brush. I mean, they were picking and identifying these very large regions of the world that were similar and talking about how their seasons are changing. But how's that impacting us? What's the impact here in the state of Wisconsin is what I wanted to focus on and think about. And, we are concerned with the temperature changes, but we also have to understand when we start thinking about seasonal changes, we got to start thinking about how this impacts the environment. And typically what we refer to those in the scientific community is phenological changes. So these are things like, the timing of when the leaves change their colors and the deciduous trees lose their leaves. This can be things like species migration, the patterns, where species travel in their migration patterns. And because of this global warming, these patterns have changed. The timing of those species migration, when it starts, when it ends, those have changed as well. We've seen changes in species emergence after hibernation, dormancy, when things start to come back alive in the springtime for us here around Wisconsin. When does the vegetation start to grow? When do we see, those first flowers of that spring season? Growth cycles of plants, and this is kind of both natural and us living in a farming community, this is impacting our farmers. The growing season. When is that going to start? How long is it going to last? These are all important questions that we need to understand because this could impact livelihoods of people. And so overall, our ecological communities are being altered because of this. And so we're going to kind of look at these temperature patterns and the changes that we've experienced since the early 1900s. And really the question that I set out to answer was, does our definition of seasons need to change? Now, as a meteorologist, climatologist, when I was in school, this is how we define the seasons. Winter is December, January, February. Spring, March, April, and May. Summer, June, July, August. Fall, September, October, and November. That's how seasons have been defined by meteorologists, climatologists for years now. Now, there's also, astronomical definitions of what those seasons are, marked by our spring and fall equinoxes, our summer and winter solstices. And so that's, again, kind of that traditional view. But again, that research article that I read really got me thinking, like, are those definitions right? Should we be altering or changing those? So we are going to first start there. We're going to talk about those traditional seasons. We'll look at how temperature patterns have changed over time here in Wisconsin since the early 1900s using those traditional definitions. But then I also want to use the Wang article that I read and got me thinking a little bit more about this question. I want to use their definition. And let's not get bogged down here in like hardcore statistics or anything, but we live in an area on our planet where, we experience all four seasons. We have a summer, we have a fall, we have a winter, we have a spring. And Wang made the argument that places like Wisconsin, statistically, they should have 25% of their days in each of those seasons because they experience the seasons. We have those seasonal changes. And so we're going to use those criteria and definition to maybe re-examine our definition of what a season is for us here in Wisconsin. So to do that, we have to have, number one, we have to have long-term records. We have to have reliable records. And for the state of Wisconsin, we've got 4 cities that have kind of long enough term records and reliable. These are weather stations that have been around since the late 1800s. Most of the time, those stations are manned 24 hours a day, 7 days a week, 365 days a year. So there's some human intervention that can, when we got to this automated weather observation, in the 80s, we continue to have that manpower there to just double check the data that was being recorded. So we have 4 such stations across the state, and we're going to use those to kind of re-examine what it means to be in a spring season, a summer season, a fall season, a winter season. And again, using kind of those definitions, maybe, if technology will work for us here. am completely locked up here, Carrie. Yep. Okay, I think we got it back now. Sorry about that. Little glitch in the computer here. So what we're going to do, again, we're going to use Wang's definition of what a season is. The lowest quartile, the lowest 25% of the days, and again, since the early 1900s, those are going to be classified as winter days. Top 25%, that highest quartile is going to be summer season. We then can determine what spring and fall will be, because again, spring is our transition from winter to summer. Fall is our transition from summer back into winter. And so we can look and use those definitions there. And what we're going to do is, what I did was look at, counted the number of days in each season. How are they changing? Do we have more days that are occurring in one season or the other using that criteria? But also looking at the timing, the start of those seasons. Is that changing? Again, how should we be defining those seasons? Do those traditional seasons still fit here? Or do we need to be thinking about another way to define seasons? If you've paid attention this year, we've had a pretty crazy fall season. We're in the final month of technically our fall season. We're starting November 1st now. Hasn't felt like fall yet. Traditional fall throughout September and October. So I'm really interested to get this year to end and get the official stats from this year as far as the temperature records to see how much different this year has been. Especially here in the southern part of the state, but really all over the state. I was just up in Door County this weekend, and same thing that we've been experiencing here, well above normal temperatures through these first 2 months of traditional fall. Do we need to be changing those definitions? So let's start big picture, and then we're going to kind of hone into those areas. So in terms of statewide, if we look at all the temperature records that have ever been recorded across the state of Wisconsin, and again, we're going from 1900 to 2020, 120 years worth of data here. We can see that annual temperatures have increased by almost 2 degrees Fahrenheit. In the early part of the 1900s, if you kind of look at the line graph there very quickly, you can see kind of a lot of those points are right around that 42-degree mark. Go to the last part of the graph there, the far right-hand side, and you can see there's a big grouping around 44 degrees Fahrenheit. We have seen an increase of about 2 degrees Fahrenheit in our state. Again, we'll talk a little bit about maybe some of the implications of that. But that hasn't been uniform throughout the year, okay? Winter has seen the largest increase, 3.5 degrees Fahrenheit of warming in our traditional winter season over that time period. Our spring follows behind that at 1.8, and then we've got summer and fall right there around 1 degree Fahrenheit change over that. So it's not evenly distributed across the year. Winter season has seen more warming than the other parts of the year. We can also look at this spatially. So every state in the United States is broken up into climate zones. Here in Wisconsin, we're broken up into 9 different climate zones, and you can see them mapped out here. We just simply number them. We got climate zone 1 up in the northwest part of the state, and we can see the numbers. We are located in climate zone 9 down in that southeast part of the state. So we can examine those records by these climate zones as well, because again, it's not uniform across the state. If we look at those annual temperatures, we can see that the northern part of the state has seen more warming than we have here in the southern part of the state. We Again, we're in that climate zone 9. We've experienced 1.5 degrees of warming down here in the southern part of the state. Whereas up north, you can see climate zone 3 there at 2.8, the largest change. If we look at those seasons, those traditional seasons, again, same thing. Winter is our season that is experiencing the most warming, and again, most of that warming for our state has happened in the northern part of the state. We're down here, climate zone 9 at 2.9. Go to spring, again, that second largest change. Again, most of the change, the largest change has been happening up in the northern part of the state. Summer, again, kind of this very similar pattern, just changing not as much. And then fall. And this fits what we should be seeing, because the changes that we've seen are due to humans. We are putting more greenhouse gases in the atmosphere. That has an impact on what we call outgoing radiation. Well, that outgoing radiation is more important in cold seasons, cold times of day, cold locations. That's where we're seeing the most warming. That's when we're seeing the most warming, is during those times when that impact of that outgoing radiation has more of an influence on our temperature patterns. So that's kind of big picture. And again, kind of using traditional definitions of what a season is. Using that, December, January, February for winter, March, April, May for spring. But like I said, my question I was set out to answer is, are those definitions true? Is that what we should be using to define our seasons? So to do that, to kind of analyze this, we have to go in, we have to get higher resolution data. With that state data, that climate zone data, I can get monthly values. But here, when we start looking at particular cities and locations, now I can get daily data. I can see every single day that temperatures have been recorded in this state at these 4 locations, which we're going to analyze. Now, obviously, the big missing piece here, which I'll talk about a little bit at the end, there's no stations like that up north, okay? And so, really we're kind of focusing on what's happening here in the lower 2/3 of the state. We've got Green Bay, La Crosse, Madison, and Milwaukee there. So let's first take a look at Green Bay and look at the temperature patterns and the temperature changes that we've seen in Green Bay in that time period. So here's a graph. Again, we've got more detailed data when we start looking at these individual stations instead of kind of aggregating it across the state or those climate zones. So your top red line, this is the annual maximum temperature. So the highest temperature recorded every single day, average throughout the entire year. What was it each and every year? And again, we're going from 1900s to 2020 over on your right-hand side. The blue line is minimum temperature. Black line is your mean temperature, just taking the maximum and minimum and getting an average of those. So with Green Bay, over that time frame, their maximum temperature has increased by about 2 degrees. Their minimum temperature hasn't changed over that 120 years. And the mean temperature has increased by about 1 degree Fahrenheit over the 120 years. Using our traditional seasons, maximum temperatures have increased the most in the spring season in Green Bay, an increase of around just over 3 degrees Fahrenheit. Minimum temperatures have increased the most in the wintertime. Again, this is what we would typically think would happen, those cooler times of year impacting the minimum temperatures the most, because that's when that outgoing radiation is impacted the most. Mean temperature for Green Bay, the largest warming occurred in the winter season, just under 2 degrees Fahrenheit there. Gonna throw a lot of numbers at those stations. Again, at the end, we'll kind of wrap up and what does all this mean? What kind of impact are we having? Again, are those seasons how we should be defining them? So let's think about that new way we can define seasons. Again, top 25% days would be classified as summer. Lowest 25% of the days would be classified as winter after ranking all the temperature data. So in Green Bay, they've lost 12 days of winter in that 120-year span. Those 12 days spread out, and we saw the increases in the number of days that would be classified as spring and fall, with 6 in each. The number of summer days stayed pretty constant from early 1900s to 2020 here in Green Bay. If we look at the temperatures on those days classified as winter using this new criteria, wintertime temperatures increased by just over 1.5 degrees. Summer temperatures remain the same in Green Bay. Again, you can maybe start thinking about maybe some of the impacts this might have. Those could be good impacts. Those may be bad impacts. The other important thing here, again, that I wanted to look at is, what about the timing? When are these days starting? So in Green Bay, the start of the winter season averaged around November 23rd at the beginning of the 1900s. Now it's averaging a start around November 27th. So right about the end of this month. So about a 4-day shift there. Summer season, we've shifted from a start around May 25th to May 22nd in Green Bay. Getting a little bit early. May not seem like a lot to us, but to other species, this could make a big difference. This 1.5 degree change, this shift of even 4 days can have an impact on ecological communities. If we go to La Crosse, again, a little bit north of us and over on the west side of the state, kind of opposite there of Green Bay for us, and we see some very similar things. Now, with La Crosse, you'll notice, and I will point out, mid-80s, we were missing a lot of data from La Crosse, so I just took that out and did not use those years to analyze. It just, again, for the most part, these 4 stations had continuous data. There was like a 3-month period in La Crosse where they were just missing a lot of data in the records. And so I just wanted to kind of eliminate that and not use that for any analysis here. Same thing that we saw in Green Bay. Maximum temperatures have increased by about 2 degrees. Minimum temperatures here have increased about just over 1 degree, and your mean temperature about 1.5. Very similar to Green Bay. Using those traditional seasons, again, maximum temperatures increase the most in spring, around 2.5. Here in La Crosse, we actually saw an increase in both winter and summer in terms of the minimum temperature. The summer surprised me. Again, we typically think that this is going to happen the colder times of the year with those minimum temperatures, the wintertime temperatures. But we actually saw that minimum temperature in summer also increase. Mean temperature in summer also increased the most here in La Crosse, about 2 degrees Fahrenheit. Using the new definition, La Crosse also lost, on average, about 10 days of winter throughout the year. Those were gained in both spring and summer season for us. Remember, in Green Bay, it was spring and fall. So both of the spring and summer here in La Crosse gained 5 days. Temperatures still increased there in winter and increased in summer season. Same kind of shift. again, about 4 days later, that winter season is starting. So the onset of winter has changed over the last 120 years here in La Crosse, just like we saw in Green Bay. And same thing with summer. Summer is starting a day earlier here in La Crosse. So we're starting to see some very similar patterns emerge here, looking at both Green Bay and La Crosse. Let's come a little bit closer to us. Got 2 stations, about an hour drive either way. We can go to Madison, we can go to Milwaukee, and we can see what the temperature patterns are like. And we're gonna start in Madison here. And again, look at the same type of data. What are the changes that have been occurring in Madison? So here in Madison, maximum temperatures have increased by almost 3 degrees over that 120 years. Minimum temperature has decreased by about a degree in Madison, which again was a surprising result. I did not expect to see that because those minimum temperatures, from all the research that you read about climate change, it's those temperatures that are increasing the most. But we're not seeing that here in Madison. Mean temperatures have increased about 1 degree, just under 1 degree Fahrenheit over the 120 years. Again, those traditional seasons, spring warmed the most. As far as maximum temperatures, winter warmed the most. As far as minimum temperatures, again, same type of pattern we saw in Green Bay and La Crosse. And the mean temperature increased the most in the winter season as well. So again, we're seeing these patterns are emerging across our state for us. Very similar to Green Bay and La Crosse, Madison lost 9 days of winter on average over that 120 years. Shorter winter season by 9 days. Remember, Green Bay was 12, La Crosse was 10. Here we're kind of gaining those days throughout the year. The fall increased by 6 days, summer by 2, and spring by 1. Winter temperatures still increase. And again, summer temperatures, again, we see that decrease there with those days that were classified as summer days. And just like Green Bay and La Crosse, we see both our winter and our summer season shifted. Summer here shifted a little bit more than what we saw in Green Bay and La Crosse, in Madison, and about the same in terms of the winter time days. Again, winter is starting a little bit later for us, which is what we would maybe expect with global warming going on. And then finally, let's take a look at Milwaukee. Again, Milwaukee's maximum temperature has been increasing about 2 degrees. Minimum temperature has increased about 1, and your mean temperature about 1.5 degrees Fahrenheit. Our traditional seasons in Milwaukee, maximum temperatures have warmed the most in the spring season, about, again, that 2.5 degrees. Wintertime, minimum temperatures have increased. I feel like I'm a broken record at this point, saying the same thing over and over for each of these 4 cities across our state. Mean temperatures increase the most in winter season. Again, 10 days lost in terms of winter, what was classified as winter days. Gaining them throughout the year here, just like we did in Madison. Temperatures increased in winter, increased in summer. That shift was about 5 days here to a later date in terms of the start of winter, and summer shifted by 1 day. So we're seeing the same type of patterns emerge across all 4 of these cities when we can really get down, kind of using those criteria that Wayne developed for what he looked at the global scale, go into Wisconsin, and we can start seeing those similar patterns. And this matches what Wang and his co-authors found in that paper that kind of started me down this journey in the early part of 2021 when I wasn't doing anything else because I was quarantining with COVID. So why not do some more and extra research, right? So we see these patterns. We're losing about 10 days of winter over the 120 years of records that we looked at. We're seeing these wintertime temperatures increasing. Summer increasing at most places, decreasing a little bit there in Madison. But then the start of the winter season. And again, 5 days, 4 days may not seem like a lot to us over that time period, but for species that can't react, can't adapt quick enough to those changes, it could be detrimental to them. So, no matter if we're looking at the state level, those climate zones, those select cities that we looked at, for the most part, we're seeing warming in all of our seasons. In the annual statistics, we're seeing a warming. Few instances where we have some cooling. Madison kind of stood out there. But for the most part, our temperature patterns are on the rise. This is changing our seasons. This is shifting our seasons, both the length of the seasons, but also the starting time of our seasons. That's important for us to understand. Again, we can easily adapt. We can turn that air conditioner on sooner. We can turn that heat on when we are at discomfort from that. Again, other species can't do that. They have to adapt to this. This is changing our migration patterns of some of the species that come through our state, that leave our state certain times of year. We're seeing shifts in those timing of those. We're seeing shifts in the emergence of species, plants growing sooner, because we're seeing that change, that warming that's occurring is causing plants to start to grow sooner. That is altering that growing season for our farmers as well. So that natural cycle, natural vegetation is changing, but our farmers are going to have to start thinking about this as well. And again, overall, this is changing ecological communities. When we're talking about ecological communities, there are relationships that are very important. They could be predator-prey. If that prey is coming in a week early before that predator wakes from hibernation, that could impact those species. Both of those species can be impacted by that. We have symbiotic relationships. We have mutual relationships between species. If we have a herbivore that relies on the growth of a plant and that plant is growing before that species comes out of hibernation, that's going to alter the population of those species. So there are many implications to changing what's going on with the temperature. Temperature change, again, is kind of where we start, but there's a lot of implications from that. It's not just other species. We are impacted. Winter is decreasing. The length of winter season is decreasing here in the state of Wisconsin. How's that impacting our tourism industry? What about those outfitters for snowmobilers, those ski resorts? How are they dealing with this? How are they impacted by this? Because that winter season is shorter, starting at a different time. Warming. It's harder to have, snowmobilers, skiers if there's not cold enough temperatures to produce that snowfall. You can do it artificially, but that costs a lot of money. Those ski resorts will do that, but it is a big financial burden for them to produce that. So how is that being impacted by this shorter season? These changes are causing changes in our extreme temperature patterns, heat waves in the summertime, our cold snaps in the wintertime. One of the other things that we hear about a lot in the news here lately, that polar vortex. We're coming up on that time of year where we'll probably start hearing about that. Most people think, well, how can we have these really, really cold temperatures when we have global warming going on? Well, what's happening here is the warming that we're seeing across our planet is weakening our jet stream pattern, which is some high level winds in the top of our, about 10 kilometers up. We've got these jet streams. The warming that we've experienced has weakened that. What a result of that is cold air can surge from the Arctic region down into the mid-latitudes where we live, Wisconsin. So we get these cold spells. Same thing in the summertime. With that weakened jet stream, it pushes warmer air up. So we can have these extreme warming times, these heat waves in the summertime. So these are changing. These are ways that it's impacting us. Some other research I've done, I've looked at precipitation change across the state of Wisconsin. This has been changing. And I gave a talk, COVID screwed with my timeline. I gave a talk maybe 2 years ago, Carrie. I can't remember exactly when it was, and I talked a little bit about some of these precipitation changes. We're seeing fewer days with precipitation here in the state of Wisconsin. So we're getting less days that we measure precipitation. However, the amount of precipitation we've seen has gone up. This is impacting droughts because we go longer stretches without rainfall, without snowfall. But we're also seeing increases in flooding because when we get it, we get a lot of it. And so we see these instances of flooding increasing. Kind of at the global scale, this is from Climate Interactive, which is a group that I work with and do some workshops with. These are some of the global impacts of seeing a warming of 2.7 degrees Fahrenheit, which some parts of our state are seeing. We're seeing, again, those extreme temperatures change. Obviously, we don't have coral in our area, but coral's being impacted, but our Great Lakes are. We're seeing algae blooms increase on the Great Lakes because of some of the warming that we've experienced. Droughts are longer. Heat waves are more frequent. Again, these are impacts on us. 3.6 degrees Fahrenheit of change. Again, some of those same things. Risk of river flooding, changes in precipitation, droughts. So these are some of the impacts that we could see from this. Now, where do I want to go with this? Well, my first goal is let's find a city. I'm not going to be able to go back to 1900, but maybe the 20s and 30s, we may be able to find some cities up in that northern tier just to make sure that they're seeing those kind of same types of patterns. And so that's kind of my first goal, where to take this. How's this impacting our farmers? Again, I always want to think about, as a climate scientist, I'm always thinking about not only how are these things changing, but how is it impacting us? Let's look at those growing degree days. The growing season, how is that being altered? Could it have a major impact on our farmers? Electricity demands for air conditioning, heating demands in the winter season. How are those being altered? Again, we've already lost 10 days of winter. If we continue to see that, what's going to happen to what do we need to think about kind of long terms as far as fuel supply and having those those heating demands and meet those heating demands. We've also just recently, one of my colleagues and I were working on a grant, and we've started a partnership with the Wisconsin Initiative on Climate Change Impacts, or WICI. And one thing that they have is they've produced downscaled models out to 2100. So taking some of the climate models that we have and getting a really fine resolution model for the state of Wisconsin. My colleagues already looked at some of the things like winter tourism, kind of days with snow. How is that changing? I want to start looking, again, what are our seasons going to look like in the year 2100? Okay, we're not going to be around, but my kids are, my grandkids, are going to be around, and I want to leave a good future for them when I leave. So that's some of the things that I'm looking at doing here with this information to kind of continue that. And that's what I've got. So thank you very much for joining us, and we'll open it up for questions here for a little bit, and I can hopefully answer some things for you if you have any.
In general, you found that that in all four cities, the all seasons warmth except for one. Madison summer was cooler. How do you account for that?
Exactly.
That's the $1 million question right there. um, I, I mean, there's going to be some impacts here. At first you would think, well, what kind of impact do maybe the lake around Madison have? Well, but then we didn't see that in Green Bay or Milwaukee with an even bigger lake. It's a really good question, and to be honest, I don't know what the answer is. I think I need to tease out that data more and look to see, why those summertime temperatures are being impacted like that. Because again, that was a very surprising result to me to see that temperature decrease. Again, in all other cases, the temperature, there were some locations, temperature kind of stayed steady. Whether you're looking at the minimum temperature, maximum temperature, mean temperature, they stayed pretty flat throughout the 120 years, but that was the one where it decreased. And I don't have a good answer for you. Again, I think it's more, we need to dig into that data more to see why that was in Madison compared to across the state.
My question is, how does this compare to other parts of the world? My understanding was the Midwest was less impacted by climate change than other places.
Do you know of anyone who is doing any work on the animal and plant, the effects of this climate on animal and plant populations?
Okay, you got both of them? Okay.
So let's go with the first one, which was other parts of the world. Yes, I mean, research shows that the Midwest is probably one of the areas that has been least impacted. But again, we are still seeing some impact from climate change on that and seeing those temperatures increase. There are other parts of the world that are warming even more than what we are. There's other parts of the world that have stayed pretty constant. And again, kind of painting with a very broad brush here, the closer you get to the poles is where we have seen the largest increases in temperature. And again, that makes sense when we understand that most of this warming that we're experiencing has come from what we are doing as humans. We're changing the composition of the atmosphere. We're putting more of those greenhouse gases in the atmosphere. That impacts that outgoing long wave radiation. So the energy we're receiving from the sun has not changed very much or significantly enough to alter the temperature like we're seeing. What's happening is we're trapping that outgoing long wave radiation. That's what's causing the warming. So again, the areas that are the coldest, the areas that's location-wise, polar regions, that's season-wise, winter season, timing of the day, the minimum temperatures are usually impacted the most because that's where that outgoing long-wave radiation is more important in terms of the energy budget that we look at to determine temperatures. So hopefully that was good, what you were looking for. Species response to that. There are some colleagues of mine in biology, environmental science that are kind of looking at some of these species. Again, I tend to focus more on the kind of human side of things and how it's impacting us as humans, as well as just kind of looking at the temperature change from a data standpoint here. But there are colleagues over in Upham that, which is the science building, that are looking at some of those species changes. We've got one of our more recent hires does a lot of work in coral. So he examines coral and how coral is changing. You saw the picture there of coral getting bleached, and that's one of his big areas of research is kind of seeing how the increases in the ocean temperature and ocean acidification, how that's impacting coral. And so that's an area that he focuses on. I don't know of anybody who is like focusing on Wisconsin species per se. Kind of in this area, they're more those exotic locations where we're seeing some of those bigger impacts around the world.
Anybody else in this region with questions while I'm over here?
Have we or might we hit the point of no return?
Well, if the first question was the $1 million question, here's the $10 million question that everybody tends to want to know. I don't think we've hit it yet, but we're close, which is alarming to us climate scientists. We need to act now. The time of dragging our feet and ignoring the problem has to be over. Especially in this country. Other parts of the world, they've started on this problem 10, 15, 20 years ago. Here in the United States, we've been dragging our feet on this issue, and it needs to stop soon because, we are almost to that point of no return, that this could spiral out of control. I don't think we're there yet, but we could quickly get there if we don't make changes that need to be made. That's my answer I'm going to give without getting too political. Vote, and I know I don't have to tell this crowd that. I have to tell my college students to do that. Vote, because we need people in politics that kind of understand the problem and that it is a problem and they're not ignoring it. Obviously, you hear these things. Use less energy, whether that's turning off lights, driving less, all those little things do add up over time. The other thing is that people don't realize that has a big impact on this is our eating habits. And I'm probably I put myself in a very, the bad side of this. I'm not the greatest at thinking about this, but the food that we consume creates a lot of greenhouse gases for us. We're meat eaters. That's creating a lot of greenhouse gases. The transportation of our food creates a lot of greenhouse gases. Simply buying local, buying from sustainable farms has become a big issue here lately, and one that I've really consciously tried to think about more when I'm purchasing things at the grocery store. again, just as important as going into the ballot box and voting with what you buy is too. I think we're seeing a big shift. We see, the prices of electric cars dropping. We see new electric vehicles coming out with better range on them. We're seeing charging stations pop up. All of these things are happening because on our energy grid, we've got a lot of renewables. We've got new wind farms. We've got solar power. All of these things are helping. We got to continue to promote those things, keep, getting politicians that are going to support these things. And I think the fossil fuel companies are seeing the writing. Over the last 10 to 15 years, you've seen, if you look at investments in renewable energy, some of the biggest investors now, Exxon, Mobil, they see the writing on the wall, and they're starting to put their money in those bins too, that when we get to that point where they say, we're not going to produce oil anymore, they're in place to help us produce those renewable energies. And I think that was a big tipping point starting about 10, 15 years ago, is when those companies started investing. They're like, we get it from an economic standpoint. We're starting to see it. We get it and where it's going. I think we just need to maybe speed up that process a little bit so we don't hit that tipping point.
I've just come back south from 22 years up north. In 22 years, we saw many state tree farms or areas cut down for houses to be built. Many, many people retiring to our area. Big apartment buildings going up. Everything changing from being a rural to an almost metropolitan. Not really, but it was big. Is there any correlation between that movement and that kind of activity?
That's a little bit of what's, causing some climate change for us is, we're clearing off forests. Remember, forested areas, that's helping get rid of some of that carbon out of the atmosphere that we're so worried about. And so when we, deforest lands, we are definitely impacting that. Again, I would just wonder, yes, we have a lot of companies now that go in and like clear lands, but then they're also planting in other areas. So, we got to, some of them are, again, sustainable in that sense that they're trying to replace what they're taking away. One thing in terms of population that we've seen, we've started to see, and you guys have been around longer than I have, but, this movement from being in urban centers out to the rural areas. Now we're starting to see that transition back into urban areas because people are, not wanting to drive cars as much, wanting that public transportation, which is a little bit better on the environment than, individuals driving. And so we're starting to see some population patterns change because of that. And so that may be a little bit of what, was kind of going on, is that demand is there to kind of grow these urban areas. So yeah, I mean, those landscape changes are important. I mean, mid-1800s, this area here, this was all forest and grassland area. We've cleared this out. And because the soil underneath us was good for agriculture. I mean, we're really a farming community around here. So, we did it for our purposes, but we need to, again, start thinking about that future and what kind of impact those things are having on us and on our climate.
If you have any other questions for Dr. Frye, he'll be here for a few minutes. But please go ahead and join me in thanking Dr. John Frye for his presentation today. Thank you for coming.